this is kind of where we were. So, right, you could move the cursor around, but it was like, it's just in screen space. It's not actually bound to anything, right? And everything's a little wonky. I noticed this after the last video, was if you try to run on Linux, the render function essentially just crashes out the terminal. And so what we want to do is we do if update then render. And this means we're not actually repainting the screen unless there's a reason to, right? And that saves us on the Linux side. It saves our bacon. It doesn't seem too bad on the Windows side, but it's probably better. I mean, why repaint repeatedly when you don't need to? So what we'll say is if we read anything, then we need to actually do an update. That's a pretty quick, pretty cheap way to essentially only paint when there's a reason to on that guy. In the main editor now, we probably want to go ahead and start building out what is this editor actually doing. I want to make a little test bed, and it's just going to be our fake file for now. I want to have status line, and I want it to be 1. So we want the bottom line of the screen to print out. And then we want to have a terminal. Terminal is a struct, and in the terminal it's going to have a screen, right? And that's going to be to int. There's going to be the render cursor. This is going to be the size of the screen, the printable size of the screen. So the status line is actually going to be taken off of that. This will be where the cursor is visibly like XY on the screen. And because the screen can't actually, well, may not be able to hold the whole file, we want to actually have a line offset. And that's an int. And so this is how many lines into the file is the top of the screen. And so between these two, that's able to pretty fully represent us where we are in the buffer. Then we're going to want a screen buffer, and we can make that a strings. I don't have strings in there. Builder. All right, let's get core strings. We want a screen buffer. So you're actually going to have the text buffer here. So this is the actual file that we're working on, and then the screen buffer is just a allocated block of memory for the screen. And we're also going to want one for the status line, and differently, I'm going to actually make it just a fixed array. So this one just wants to be a dynamic array, and this will let us, if we ever get to it, we'll be able to, as someone resizes the window, we can actually resize the status line. But we're not going to append to this one. We're actually just going to write into it because we want to be in certain spots, right? Everything wants to be printed in the same spot on every cycle. And the builder would make it a lot harder because you have to kind of print into it linearly. And that's not really what we want to do there. So that is our terminal, and we'll go ahead and do an allocation for it. Maybe we want to say how big's the file, right? As an int, and we'll give back a terminal. T is a terminal. No, not a string. The terminal. And then t.dims is get window size. Then we can say t.screenBuffer is strings.builder make. And so we know that it's going to be dims.y. So this is how big the screen is, and so we might as well just immediately allocate the screen size right out of the gate. So then we'll go ahead and get the status line. And similarly, that's going to be make a dynamic u8, and that's going to be t.dims.y. So how many columns is the screen? Just go ahead and instantly allocate the status line for that width. Maybe a to-do space. So fill status with spaces. And so we need to fill the status line with spaces because only, a 0 character is not going to be printed to the screen. And so we got to fill it with a printable character. And so space is going to be our guy. What we want to do is take t.dims.x, and I want to reserve that status line. That way, whenever I'm using this dimension as a calculation, I don't have to be bothered with the fact that I'm like always having to stick the status line everywhere. It's just like the dimension, I think 95% of the time, I want it as is for the main screen. And then that one time that I'm going to need it for this, I can add it, right? That'll keep life a little bit simpler. Then we want to do t.buffer.getBuffer equals, and this is, I probably should fix this, but I'm not going to for now. Make get buffer. Right, we'll pass in bytes. To do wrap text buffer. Make. Next thing we need is the screen, which is, it's really obnoxious, is in one space, whereas everything else, we're working in 0 space, and so it's just not fun. And then we want to put our file to the right, basically to the start of the file, right? So now we can return t. We'll do a to do for the destroy. Destroy. I don't know that that's really necessary because we can just let the operating system do it for us. But if you want it for reasons, we can do t is make terminal. You get 4 bytes out of the gate, right? If you don't specify anything, you get a little tiny terminal. Now that we've made a terminal, we could do an insert. So we can do t.buffer file. I called it file. So this is going to be to do replace with os.read ... We don't really need that anymore. We do want to do one render. For that render, we're going to need the terminal, right? I mean, not yet, but t is a terminal, and then update is also going to want that. So then here, here, and here, can do AMT. And so the terminal is basically our global state, so it's going to need it for all this stuff. Don't think I need to do a prior erase because we'll get that here. So what we're doing right here is we're going to do a first paint. If we look at our loop, until I press a key, the screen's going to be black, right? It's not going to have anything. So we want to have at least the first paint. We want to align the screen cursor to wherever the state thinks the cursor is. Now, we're setting it to the beginning. Oh, see, and I already made a mistake there, as it was 0, 0 when it really needed to be 1, 1. All right, we got a first paint, we've got a terminal initialized, we've got some data in the terminal. The next thing we'll want to do is we need to, once we've done an update, we actually need to make sure that the render cursor is in the right spot, and we'll write that function in a second. And then the last thing we'll want to do is move to wherever it is. t.renderCursor.y. All right. So now we'll do an update. We make sure the cursor is where the update says the cursor should be. We then render the screen. We then put the cursor, because the render might move the cursor, so we're going to put it back to wherever it's supposed to be. This probably could be down there, actually. We're going to want that function, and he's a monster. Let's not do that just yet. What I think I want to do, I want to get where we're rendering at least the status line, because then we can see what's going on in the file. And then we can put a to-do here of repaint only touched. Now, our whole system is not really designed for this, but it would be good if we didn't have to just black out the whole screen, right? If you're only touching one row, you probably could be smarter. I don't think it's worth it. At that point, I'd rather go to a full terminal emulator and be rendering like with the GPU or something. So we're gonna probably never do that one. All right, so what we wanna do is move, we're gonna move to the terminal.dims.x. We're gonna go to the end row. But remember, that one place I was saying we need this is we're gonna go on to the status line. We can do set graphics rendition, and I'm thinking bright black as our background. Change it up, right? I could use the same thing, but oops. Color fancy, and I don't know, let's do yellow. Okay, so our status line is yellow and gray. Let's just do this dot print for now. We just do printf buff then is %v, and that's t.buffer.run. That, in theory, gets us where we're printing a status line. So let's go ahead and try that. And we are. Excellent. We want that status line to go all the way across, but what's happened is, again, we won't print a 0, and all of these characters are 0. So if I want that gray line to go across the screen, I actually need to go finish doing this thing. And so we can do clear status line. Maybe does this. And we'll want to write the status line too, because it's, all right, we're going to take in a terminal. Let's do mem.set. So I want to set t.status line of 0. So basically take the first entry. I want to set it to a space, and it's the length of t.status line. So then everything in the whole status line gets written to be spaces. In the render function, maybe at the end of the render function, we'll just say go ahead and clear the status line each time. And that way, when this changes, right, we're always writing into a clean status line. So real quick, we go test that, and that was a failure. That's not going to work if we don't actually print it. T.status line. And what we can do is we can actually, for now, we'll just move right back here. We need to print the status line, but that's a can't cast from dynamic. So we need to take the dynamic and turn it into a slice. Now we'll go ahead and run it, and we've got that. So I've essentially printed spaces across the screen, right? And then on top of that, came back and printed this. We'll clean that up, but for now it's good. Once we're done with this, we'll reset it, right? So this is going to get rid of all the background colors and all that kind of stuff. We may as well do the write status line procedure. For write status line, we're going to actually use the buffer print format. We want to know where are we on the screen. So this is our screen coordinates. We're going to want to know what that line offset is, I think. Offset %v, what the file cursor is. So this is like our absolute file space cursor. And we're going to want to know how many lines we have. And holy moly, that was a bunch of stuff. We want to write into, okay. In theory, that's everything. In our update loop, right here maybe? No. We could do it here. We don't actually need, for the, so all of these things are just the state, so we don't actually need an update to occur. Yeah. We're not actually updating the state, and right, we're forcing the cursor to stay where the state says it is, so that's not much happening yet. But we at least have a nice update line down there. All right, cut that down. All right, now we've got the basics of the status line printing. We need to start working on where the screen space transform is, and This is probably the ugliest part of this here. So we'll come up to the top, I guess. We'll put it under the terminal. All right. So we want to do update render cursor. And it's a procedure that takes in a terminal. And the first thing we're going to want to do is find out what row are we on. Next, we'll want to know where's the buffer at. So we'll say end of buffer is length of the terminal.buffer. To do binary search. So I'm going to do this just as a brute force. I feel like, you know, if you wanted to be faster, you could do this. For what we're doing, actually, we don't want that kind of a for loop. We want the other kind of for loop. For starts at and I in t.buffer.lines. So for every starting point, where are we? Path start of row is t.buffer.cursor is greater than or equal to starts at. So are we past that line? Then we want to know, are we on the last row? And I'm just breaking these out because otherwise the if statement gets really long. So is I equal to the length of t.buffer.lines -1. So are we on that last line? And now we can do, say, if we're past the start of the row and we're either on the last row, on the last row, or the next line ends, or we're inside that line. So t.buffer.cursor is less than t.buffer.lines of I plus 1. We're past the start of the row. We're either on the last row or the row we are inside a current row. So if that's true, then we want to say t.renderCursor.y is t.bufferCursor minus starts at plus 1. And this is to go to one space. Oops, one space. Right, again, cursors are in one space. Then we want to say the absolute row is I and break. So that tells us what row we're on in the file. Now we have to decide if we need to move. Need to move, and that's going to be the absolute row. No, absolute row. That's probably a bad name. T.line offset. So how much of the file or how far into the file are we at right now versus the absolute row? And we'll just stick some parentheses so we can make it clear. Right, again, we're going to come out of one space, back to 0 space. All right, so then if need to move is less than 0, we're going to, oops, not 9, less than 0, we're going to go up, right? So we need to move up in the file. We'll take the balance as the minimum of how much we need to move versus the t-render cursor, render cursor dot x minus 1. And we're going to do relative movement in 0 space. So t-render cursor is dot x minus equals the balance. Oops. Balance. Then otherwise, we're making a downwards move. And I just type it, I guess. The balance is similarly the min of need to move and the screen height minus t dot render cursor dot x. And those are both, I believe, one space. We'll leave it like that. I might need the -1 there, I'm not sure. t dot render cursor dot x plus equals the balance and t dot line offset plus equals need to move minus balance Didn't update my line offset up here, did I? And do it this, whoops. So what this is going to allow us to do is we can, oops, get thing out of the way. This way, when you're at the bottom of the screen and you press down, the line offset is going to increment once and your cursor is going to stay at the bottom of the screen. Or if you go to the top of the screen, right, you're maybe on page 2 and you go to the top of the screen, you want the line offset to the file just to move up one, rather than it like flip a whole page. And then, right, that's more like Zelda or something, where you're actually like moving from a whole tile to the next and the camera's snapping. And we don't want that. We want it to be, you know, an incremental move. That gives us our render cursor. Now we want to do move the cursor. So now we're actually moving the cursor itself. And maybe we'll do the lines first. So that's all right. And that is a proc, takes up terminal, kind of common theme here. Oops. Terminal n of int. And so now we'll get both lineups and we'll be able to do page ups, you know, with the same procedure. So if there's no lines, then just go ahead and return. Right, there's nothing we can do here. Otherwise, we're going to say the row is the render cursor.x -1 plus n. And just to help with understanding that we're going back into the zero space, we'll put that on parens. No other reason to. If the row is less than 0, then the offset is the row. But kind of like a clamp, we've got to set two things at once, so we'll just go ahead and do it this way. Oops. Row 0, else if the row is greater than t.dims. This gives us how much we're needing to move, and row is t.dims.x. So this clamps us to being where the rows are always on the screen, you know, between 0 and the height of the screen that we're allowed to have. And then this offset is how much do we actually need to move. All right, t.line offset is clamp of t.line offset plus offset of 0 and len of t.buffer.lines -1. Okay, so we want to say move. In fact, let's do that. We're going to do need to move, and we'll just grab you and stick you there. Nope. So we're saying, you know, between 0 and the last line of the file, that's how much will be offset. Technically, I don't think you can get to an offset past the last line, because the cursor, it's almost like that minus the cursor. All right, so then our absolute line is similarly, we're going to clamp again of t.line offset plus the row. And that's again, same thing. We're going to clamp there and grab this guy. Now we can say starts at is t.buffer.lines at the absolute line. And then the column is going to be the minimum of t.rendercursor.y -1 and t.buffer on the absolute line, not absolute function, absolute line, then -1. We can then say t.buffer.cursor is starts at plus the column. Okay, so actually, I think I am going to fix this here. So I'm going to say minus t.dims.x. And what that'll allow me to do is I don't actually need this other clamp. So this can go away. So we're clamped between, you know, we're clamped between the offset and how much we need to move. We can't go, you know, less than 0, and we can't go more than the number of buffers less the. In fact, this one's. So if I have no lines, this could go negative. So we're going to end up needing, kind of obnoxious really, but do a max there. Maybe this wasn't quite as awesome as I thought. I was totally getting rid of the clamp, but we're actually adding another comparator there, but not much of a choice. Okay, so this allows us to get us through on lines. And then now we've got up, down. Now we want to get left, right. So we'll go ahead and do that. Move cursor by runes. It's another proc. It takes in a terminal. And we want to know how many want to go. And kind of the same general business. So I'm a little torn on this one. Maybe we say to do, maybe move into text buffer. And the reason for that is in the lines one, we have to actually know what the screen is. And with this one, we really don't need to know anything about the screen, right? We just need to know where, like how many runes you want to go, and we can just do it. And that puts them kind of a different class. So certainly, like I say, it probably should get there, but we'll save that for another day. So if we want to move in to the right for I less than n, so if the cursor is greater than the length of the line, then we're going to break, and our rune size is, we're going to use utf8.decode rune in bytes, and it's going to be the buffer to the cursor. All right. Then we can say the cursor plus equals the rune size. That's that one. I think we can do pretty close to the same thing. We'll take this, drop it down there, and it's going to be for I of 0, I greater than n, I minus n. So then if the cursor is less than 0, or actually less than or equal to 0, really. So we're at a runway, we can't actually read anymore to the left. Same thing, we can say the rune and the rune size, and then we want to do the other direction, and this also is, I think it's decode last rune in bytes, and similarly we can subtract it. And that gives us where does the cursor need to go. From there, we can go ahead and write that back into, oops, our cursor is clamp of the cursor, and this clamp is probably redundant, but I'm going to do it anyways. T.buffer, and then it's another one down. Now we want to know how much of the file is visible, and so we had that print range function, and so now we can take and look at which cursors are like which start and end cursor would give us the visible part of the file. And so the start cursor is going to be t.buffer.lines, and that's going to be at the line offset, and then the last line is going to be the minimum of the length of t.buffer.lines and -1, and t.line offset plus t.dims.x. Then if the last line is the length of t.buffer.lines -1. If we're on the last line, then the end is, oh, actually, you know what I want to do is we're actually going to return these as a pair. So let's say start as an int, end are ints. So I can just do an assignment. End is the length of the buffer, and t.buffer. And then otherwise, the end is t.buffer.lines of the last line. Return. Done. Okay, and I think we need this because we don't, we're not capturing like the end of the file last line. And so when we access this guy, we would actually need to access the next one, right? We don't have it, so we'll just directly measure the length. All right, and I think that is that one. All right, I think that's a lot of what we needed. I'm pretty sure we're down to just getting the update and the render functions done. One of the things I was thinking about here is that we really want to have, no, we're gonna have this just in case the second character for some reason could be an escape. I don't know that that can happen or not. I think when I was prototyping this, it did happen to me once, and so we'll put that there. You know, to do is this really needed. The next thing I want to do is print the status, like on the status line, I want to print the, like what's being typed in kind of a raw format. That way we can, you know, help us build the tool and kind of see what are they up to. So right after we read it, we'll do like a status print. And then here we can do print buff. And I think what we need to do is we're going to do a tprint. And the reason for that is I want to write using the bprint, but I need to know how much I'm writing. And I'm in this, in red, chicken and egg scenario. And I guess because we're using tprint, we'll just do a free all on the context. Temp allocator. In reality, you don't probably need to free that, but it doesn't hurt. So now we can take and do the bprint. Bprint of t.statusLine of t.dims.y minus the length of the print buff, right? And I'm going to take, basically, I want to find the subslice where I'm coming from the end and I'm backing up the length of the user input. And the tprintf is going to do a little bit of formatting. It's going to give us arrays and commas and things like that. And that's really the reason why we need to pre-print it into this guy before we write it into the other one. And then we want to print the print buff into that guy. So we can go test that real quick. Now we can run that. And when I press a key, you can actually see down here in this bottom right corner exactly what's being pressed, right? So like things like maybe control left arrow, right? It's a pretty big sequence. Like there's your escape symbol, your bracket. I think that's the bracket. There's a big sequence we got to get through. And so seeing all that just right in our buffer makes it a lot easier to kind of understand how to add features. Okay, so now we're here. The next thing we want to do is probably, let's move our escape up here. So the first thing we're going to do is, like, you know, be able to quit, right? And so if we get a quit command, we immediately want to drop out of the loop and then exit, right? Then from there, we'll want to do, there's not an else here. Then we'll have if jar is, we'll do ESC, right? And that's 1B. So then I can take you, if it's the escape, yeah, we're going to move this chunk of code here. So if we got an escape character, we then want to see, maybe it's our arrows, right? We're going to go in. Now that we're, you know, now that we know we're there, we can actually get rid of this. We can use our new functions, right? Move cursor by lines of the terminal. I'm going to go up a line here, down a line there. Move by rooms on the terminal, and we'll go left here and right there. This gives us actually working in screen space. Then let's go get these guys and mark them also. So we'll have del, which was 7e, and backspace was 7f. PKSP. All right. We can come back up here and we can say case, if we got the case 0x33, which we saw in the console, then we might have a delete or a backspace. So we can say if buff right? And it was after the 33, so we'll say buff equals del. We can copy that, put that there, else if is a backspace, bksp, right? The backspace, we want to do a remove and t.buffer, and we want to take the t.buffer.cursor, and we want to move backwards 1. And then the same thing here, but we're going to delete going forwards by 1. That gives us, cut that out of the way. So that gives us the escaped version, right, for sitting inside the control codes. But we're going to have exactly the same thing. I just want to try this out on Linux. It just is 77F, just in the open characters. So we want to put that there. Once we're in here, so if we know we're at it, we had an escape, we don't want to process anymore, at least in the setup we have right now. So now we can do the block here, and that becomes an else if, right? And if it wasn't any of those things, then we should, in theory, be plain text. I mean, there's still other characters and features we're missing, but we're getting close. So exactly the same, right? And this is like for POSIX, right? We'll say POSIX. In this block, I'm going to cheat a little bit because on the text buffer, we said we only took in strings. However, this loop we're in only produces single character inputs, right? Maybe it shouldn't. So we say to do process more than one char at a time. Where this, this is going to fail is that if you paste something in, although paste comes in on a control code, pretty sure it comes in on a control code. And so maybe this works. I don't know, but it's a little cheesy. We're going to create an array and then take the slice to give us rows of string, right? And that's if char is a new line, or char is a carriage return or a new line, then we want to do an insert at and t.buffer and t.buffer.cursor. No, that's right. I'm going to put a new line in instead. Else, we're going to put in s, a slice of s, as a string. All right, so on Linux, the carriage return when it is problematic because these are commands that are actually altering the terminal and it's a cursor position in the file. It gets really tough to manage when you have like rn or n and it's mutating the cursor as you're going while you're doing it. And so it's a lot easier if we just deal with ends exclusively, and we're going to basically fake it in for the carriage returns. That'll make our life, like I say, substantially easier. The Windows doesn't care, but on Linux, the carriage returns, they wreak havoc on the terminal. All right. That guy, I believe, is about done. Now we're on to render. All right, so on our rendering, we've got the status codes recording the screen. We then want to go ahead and paint the main body. So we can say start end is get visible cursors of t. And then we can say a print range of and t.buffer. We're going to put it into and t.screenBuffer from the start to the end. Just for testing purposes, maybe we'll set this to set graphic rendition of dot bright black background, and just to change it up, we'll do this one as a bright cyan background. Yeah, that'll work. Just so they're not the same. Then stir is strings, to string of the t.screen buffer. Now gets the tricky part. So when you're on Linux, POSIX really, I guess, the carriage returns are kind of ugly, but when you're on Windows, it doesn't really care. So with Windows, you can just print directly that string and it'll look right. But again, on the POSIX ones, I need to actually, maybe we can make a note. POSIX really wants -r on the screen, and we don't in our buffer, right? So what we can do is we can just completely bake it in. So we'll say ci inster is if c is a new line, we'll do a print of the string of str sliced from the previous to I. Then we'll do a print of our in, and we'll say prev equals I plus 1. And notice I'm not printing the new lines, right, because this is exclusive. So I'm not actually printing the new lines with the buffer. I'm attaching an rn instead, and this kind of fakes it in for us. Then we'll do one more print of the everything that's left, right? Because we might have, like, say, the scenario where there are no new lines or something like that. So this just takes all the rest of the data and dumps it out. Then we can do, down here at the bottom, we can clear and screen buffer, t.screenBuffer.buff. We're going to dump everything, and we're going to reset the graphics mode. All right. Now that we have all that, we'll run again. We've got a minor bug in the text buffer. When we're printing the range, it really needs to be less than or equal to. But because since we're exclusive, right, this definitely, yeah, that's one bug. All right, so the file cursor is moving around correctly. Press down, things are moving. The second down is not working, so we got another bug there. What happened to my screen? While the camera was cooling off, I went ahead and debugged the code and found a handful of errors. So I figured I'd just run you through those real quick. When I pasted the delete and backspace down out of the escape, I had left the +1s, right? So there's our +1s. And out here, it's not supposed to be, right? That just is the code exactly. So that was some of them. Then I had this commented out still, and so the cursor could move because we weren't telling it to. For convention, it seems nice to put the file cursor at the start of the file so it's not in some weird place. This thing will move the cursor, so we're just basically guaranteeing it starts the file at every time. On this one, my clamp, where I tried to combine the clamps into one, didn't work, and so I just reverted it back to what it was before. And in the text buffer, I accidentally had typed right or left. Yeah, I typed left right there. Yeah, so that was left, but it was the right branch, so that was a typo. So this is the one we found earlier where it's less than or equal to. On this one, I knew I was stashing this left length for a reason, and then I forgot to actually use it. So each of these needs subtracted off on all of the right strings, and I didn't do that before. With that said, we can run it. We get up, down. We can move up through the spaces. We can paint things, right? I can do deletions. I get delete. I get backspace. And all the status is down here at the bottom. Let's see here.